Hi everyone, welcome back to my channel Digital Screeny on YouTube, and if you haven't already subscribed to this channel, it's never too late. Hit the subscribe button right now. I'm back with another video as part of my Python tips and tricks series, and in fact this is more of an explainer video rather than a tip or a trick, where I'm going to explain a little bit about random in Python. Or usually what I'm gonna talk about usually applies to any other coding language also, but just want to explain this random function as it relates to computer programming. The reason I'm showing this TV screen with some noise on it is, as you can see, it shows some random noise. Where is it coming from? Primarily, it comes from the cosmic microwave background radiation that's all around the universe, I should say. And on top of that, you of course have some radio waves noise that gets overlaid, and sometimes you may see some patterns in this, which is of course some sort of a structured noise that's coming from some other man-made sources. Usually, if it is truly random, you should see something like the image that you see on the screen. And for those of us who probably, grew up, especially in India in 70s and 1980s, this is a common sight before the actual programming starts on TV. So most of you probably can relate to this if you're from that time period. Okay, so let's go ahead and discuss about random. And as part of that, I'm also going to talk a little bit about birthday paradox. I'm not sure if you guys know what it is. The reason I'm going to talk about birthday paradox is because it kind of relates to this random. Because let's say you have 1 to 1,000 numbers that you want to randomly pick from. And you would think that it would take like 500, 700, or even 1,000 tries before a number gets repeated. So if randomly you pick a number, it's like, okay, 25. And then you pick something else, and something else. And then how long does it take before you can get back to this 25? 25 gets picked. In our mind, we would think, oh, that would take like 500 tries or 1,000 tries because we have 1,000 numbers, but it's more often than that. And for that, I would like to explain the birthday paradox, which is basically you have a collection of people. You go to a party and you see like 100 people. What is the probability that 2 people share the same birthday? Good fun exercise. So I thought maybe I'll just include this. Okay, now let's jump into the code so I can just explain a couple of things about random, including the random seed. And again, why am I doing this video? As always, whenever I do these type of Python tips and tricks, primarily because many of you asked me about it. And the key question that many asked is, what in the world is this seed? Like, why are you using number 42 for the seed, and so on. So let's jump into the code and answer one of these one by one, just in a conversational way. Okay, let's jump in. And I will share this code with you with all the notes that I included right here. So you just focus on listening for now. Okay. I don't want to read the entire notes, but a couple of key aspects from here. In computer program, random is not really random, because a true random means it just happens in nature. Primarily when you look at, for example, the gamma radiation, like from nuclear materials. When you have a radioactive decay, you have these particles coming off these materials. Usually that is in a random way. Of course, there are other ways that you can kind of simulate this randomness, like in nature, where you can build, not simulate, but you can actually create these or generate these random numbers. You can have a device that reacts to the surroundings. And if things are happening in the surroundings in a very random way, or maybe, I don't know, count the number of raindrops if it's raining outside, and within a given time frame, and use that as your initial seed before calculating your random numbers. So in nature, it's possible, but when you're doing computer programming, it's always you start with a number, and the next random number gets calculated somehow using this seed value. That is where the seed comes from. Okay, so that is your and the term for this, in fact, it should not be random, it should be pseudo-random. So what we are generating in computer programs is a pseudo-random number. And it gets generated by performing some operation over a value. Like, think of it as, okay, you start with a initial seed of value 25. And for the next number, let's say you just square your 25, which would be, I don't know, 625, I guess, and then take the middle value and then square it and then add something and then do a factorial and then do something else, right? So you create some sort of an algorithm to come up with how to pick your random number. And there are various algorithms that are proposed, and the one that Python uses by default is Mersenne Twister. So I have a page open right here for that program in Wikipedia. You can see, learn a bit more about this algorithm, how it works if you're interested in that. For this exercise, I am going to focus primarily on the Numpy version, like np.random. It doesn't matter which one you use, they're both equally good. And the one from Numpy actually uses the Permuted congruential generator, and you can read about it on Wikipedia if you are interested in learning more. And these are very simple algorithms actually, so it should be pretty nice English reading English reading exercise for you if you want to read through these. Now let's get back to our code and start looking at a couple of these so we understand a little bit more about random. Yeah, there's nothing groundbreaking, there's nothing completely new that you will probably learn in this video, but I hope you at least nod your head when you're listening to some of this commentary right here. Okay, let's start by importing our Numpy. You know what that is. You probably know what matplotlib.pyplot is. We are going to plot a couple of random numbers to see if we can get a screen that looks like the TV screen that I showed you earlier. Let's start by just generating 10 random numbers. How do you do that? Whether it is regular random in Python or numpy.random, I am going to import rand from numpy.random. There is also something called randint, which gives you an integer. This is just a random number which gives me a value between 0 and 1. How many of these values do I want? 5. It's easy with Numpy to generate 1-dimension, 2-dimension, multi-dimensional random numbers. That's why I am using Numpy right now. Okay, so let's repeat. Let's generate 5 random numbers each time, and let's do that 10 times. Why am I doing that? So we can see how random is pretty awesome. You see that initially it gave me a value of this and then 0.05. So these are the 5 that I got. In the next iteration, it gave me a different random values. This is how you can kind of get as close to true random when it comes to computer programming. But sometimes you want to fix that random number. This sounds odd, but we want a reproducible random number. Why would you want to do that? Well, when you're doing some sort of a computer simulation based on some sort of a seed that gets this random number started, you want those experiments to be reproducible so you can validate and you can verify under a given condition how does your algorithm perform. And I'll give you a specific use case right after we check the next part here, which is let's print 5 random numbers exactly like before, except before executing my np.random or numpy.random, I'm going to fix my random seed to a specific value. And in this case, I'm giving a value of 42. I always give a value of 42. You may find some code online where everyone's using 42. And interestingly, someone asked me, why is this? Why is 42 special? You're not geek enough to know why 42 is special. I feel sad for you, man. 42 is the answer to the life's ultimate question and universe. So if you don't know what that is, go ahead and Google search for it. Okay, I like to use my random seed to be 42, but it doesn't matter. Give any number. So let's go ahead and run it. And you see now I'm getting random numbers. These are all random, but the same random number gets repeated every time I run this code because the seed that goes in, the first value that it goes in is always the same in this case. In this case, the first value that goes in, because I haven't defined it, it randomly generates the initial seed and then changes it every time. So this value may repeat later on, but every time the seed changes. So if I change my seed to, I don't know, 21, half the answer to the life, I guess. And let's go ahead and run these lines, and you should see completely different random set of numbers. You see, compared to these are different, but still reproducible because each time it only uses the seed of 21 right there. So far, so good, I hope. And why is it important for machine learning data sciences? Because, for example, if you have a whole bunch of training data, you want to divide that into training and testing and validation data. You want to split that data into 80% for training, 20% for testing, and so on. So let's simulate a situation like that. And when you do that, when you run your training, when you run your experiment, you get some set of results. But if you reproduce that experiment again, you want to get the same training data and same validation data. If that changes, then the experiment is slightly different. But in an ideal world, you would do that. You would actually get a specific split, train it, split it again in a different way, train it in a different way, train it, and get like some sort of an average or something. So the different techniques, again, let's not deviate our focus here. Our focus is to understand random. So let's come back and go ahead and import our train test split. Hopefully you know this, especially if you come from machine learning background. What does it do? I give a data set with X number of data points or n number of data points, and this function can split that into whatever ratio that I ask it to do, split this into. So let's create our data with 10 numbers. So let's say our data is these numbers. Okay, now I want to divide this data into a size of 60% for training and 40% for testing. So if we do that, I'm going to say A is my train, B is my testing. So in A, I should have 6 data points. In B, I should have 4 data points. Let's go ahead and run this. And when you see up here, you can see my A has 4 data points and B has 6 data points. I guess I said test size instead of train size, but that's okay. So we have 4 and 6. And keep an eye on these values, 0.069 and 0.49, right? So let me, I'm going to keep an eye right there. Don't move your eyes. I'm going to run this line train test split one more time to see what happens to those values. They're changing. Every time I run this, because it's using a random seed to randomly pick 6 data points in my data and assign that to the test or to my B right there. So if I run it one more time, you see how it's changing right there. This means if I want to reproduce this experiment using the same input data, then I have to keep that fixed. This is exactly where adding my random state helps. It doesn't matter what value you give right there. It can be 0, it can be 100, it can be whatever, you know. So go ahead and give a random state value. Now let me go ahead and split this. I'm going to call this C and D. So these are the 2 values that it picked. Now, no matter how many times I run it, so I am zoomed onto this. Digitally, I'll zoom into this area, but I am running it one more time right now. Nothing changed. Okay, so this is the key reason why we have to fix a random state or random seed, if you want to call that, because the random seed is the first input that the random algorithm takes in before calculating the next random number. It sounds weird that it's calculating a random number because random is something you pick like a lottery, but that's not how the random works here. That's why random is not truly random. It is calculated based on some sort of a seed value using some sort of an algorithm. Now, the next question is, in fact, before moving on to the next question, I quickly want to show you that with Numpy, you can generate multi-dimensional random numbers very easily. So let's go ahead and run this 5 times. Again, I'm fixing the random seed, and I am using np.random.rand. This time I'm defining my array as, instead of one single value of 10, previously we did that, it generated 10 numbers, I'm going to generate 512 by 512 numbers in X and Y. And then I'm going to plot these numbers. This is how I want to see our cosmic microwave background like, no, not cosmic microwave background, the cosmic rays, or the background. Sorry, I'm trying to struggle to find these words. We are not mapping the cosmic microwave background in the universe. We are mapping the interference from the cosmic microwave background into our TV antennas. So that's what we're trying to plot here. So in summary, I'm generating 512 by 512 random numbers, and let's go ahead and run that, and there you go. So this is 512 in X, 512 in Y, and these are all random numbers. And you can just say in 50, for example. Let's run that, and there you go. So it's 50 different plots that I'm doing. I don't know if you can see these, but when I move from one plot to the other, let's go back to 5 so it makes it easy for you to see. If I drop this np.random.seed, by the way, I'm going through different images. They all look exactly the same because we are generating exactly the same random number. Now that I dropped the random seed, when I generate these 5 plots, when I do this 5 times, you should see 5 different plots. You see how on the screen it's changing? So this is the last one. Let me go back one. There you go. There you go. There you go. They're all random. Yeah, they're all random, but they're all completely different random because the seed is not fixed. And if I fix the seed, it should be exactly the same random numbers no matter how many I'm generating. You see, all these images, they are the same. I'm switching between them. They're all the same. Okay. And yeah, I mean, in this case, these are all random numbers. Now you can fix the random, random numbers between 0 to 1, which means 0.01 or some decimal value there. If you would like to generate integers, the only thing that you need to change is instead of rand, change it to rand int, in which case you need to provide the range between which you can generate the random numbers. So I'm giving a range of 0 to 500, and let's do 512 by 512 just like I just showed you, and with the random seed turned off. So we should see 5 different images now, this time with all integer values right there. Okay, I think we now understand what random is all about and what the role of the random seed is as part of our code. Now let's go down and answer another question. Okay, if I have numbers, let's start easy. If I have numbers between 1 to 100, and I'm randomly picking some numbers, unlike a lottery thing where when you pick the number, that number is not available for the next pick anymore. In this case, think of it as, okay, you pick a random number, you tell everyone, hey, this number is this, put the ball back, and then mix it, pick a random number, and you tell everyone, put the ball back. And how many times, after how many tries, do you start to see some sort of a repetition of your numbers? That is the question. So how random is this random? Or how often does this actually come? How often do these numbers actually repeat? So let's generate a random number between 1 to 100. Let's pick a random number between 1 to 100, and let's do that 5,000 times. Just keep picking, and let's raise an exception if the number already got picked. That's what this part of the code does. So all I'm trying to see is, after how many tries do we start seeing repetitions? What do you guys think? I mean, before I run this, I wish this were interactive courses so I can get your feedback, so I can interact with you. But unfortunately, this is one-way communication. But think about it. I'm trying this 5,000 times. I'm picking a number between 1 to 100. How many tries before we start to see any repetition? So let's run this now and see. So the number 44 got repeated at try number 7. So it took only 7 tries before the number I started to pick the same number again. Let's run this one more time. So the number 51 repeated at try number 7. That 7 is a coincidence. Let's run this one more time. The number 14 repeated at try number 9. So we are repeating our numbers like literally within the first 10 tries, even though we have an option of 1 to 100. This is a bit counterintuitive. We may think that 100 numbers, so it must take at least 50 tries before we start to see the same numbers again. This is what I want you to understand about random. Yeah. So let's add 2 more zeros. Why not 3 more? 100,000. Okay. For those of you watching from India, I believe this is, what is 100,000? 1 lakh? But you know what I mean. 100,000 right there. So let's go ahead and run this and see. So think about it. We are trying to pick a number between 1 to 100,000. And after how many tries do numbers start to repeat? So let's go ahead and do that. And 752. That's not bad, right? I mean, within 1,000 tries, even though we have 100,000, within 1,000 tries, we start to see the repetition. Here it's only 600, only 400, now 200, it's decreasing, and repeated at try number 66, now 138. You see, the repetition, the highest number we saw, no matter how many times I do this, is about 1,000, and most of the time it's averaging around 300 to 400. As you can see, now it is 700. So within about 300 to 400 tries, we started to repeat some of the numbers, if the total sample size is 100,000. So if you really don't want to pick the same number again as part of your code for whatever reason, then instead of using random.randint, go ahead and use random.shuffle in Numpy. Okay, that's a quick note. Now, because I mentioned about this, I think I should also talk about the birthday paradox, which has to do with this type of explanation. The question is, you have at your party 100 people. What is the probability that 2 people will have exactly the same birthday? Initially, when I saw this question, I'm like, that's simple. My birthday is, let's say, May 27th, and if that's the case, how, I can calculate, like, okay, what is the probability of someone else having the same birthday, because there are 365 days, and I did like this normal probability. But the problem is, we humans are very egocentric. The moment we talk about this birthday, we're like, oh, my birthday is this day, so let me think about how. No, the thing is, don't think about your birthday or anyone's. There are 2 people. The birth date is not fixed for anyone. We are saying there are 365 days and 100 people. What is the probability that 2 of them will have exactly the same birthday? And believe it or not, it only takes 23 people at your party to have a 50% probability that both of them will have the same birthday. When I saw that the first time, I'm like, that's ridiculous. You can have, I mean, because there are 365 days. In your mind, you're like, it's got to be at least half of them, to be in the room for the probability to get to 50%. But this is not a paradox. This is more about, if you understand probability, you know exactly what the problem is here. So there's a nice Wikipedia page that talks about this. So let me click on the link right there. It talks about the birthday problem, and in fact, you see here it shows that the number of people versus what is the probability of a pair having exactly the same birthday. 23 people, 50% probability. Yeah, and this is the power of repetition, right? This is the power of this. I just showed you how many tries does it take. You would think that 100,000, you need a lot of tries, but no, you just need 300 to 400 tries to start repeating or to start matching the values. So we rephrased this problem as a birthday paradox problem, where we are trying to match the 2 birthdays. Yeah. So that's exactly what this part of the code actually does. And go ahead and read the Wikipedia stuff. They actually give you all kinds of details. So all I did in this code is just take this. The probability of not a match is factorial total number of days divided by total number of days to the power of how many people you have, multiplied by that total number of days minus how many people you have, factorial. So this is the probability of not having a birthday, and 1 minus that is basically the probability of the 2 people having the same birthday. That's exactly what I did as part of here. This part, you see, I have total 100 people. Factorial 365 divided by 365 to n, and blah blah blah. And my let's do this. Let's go ahead and import. My total number is 100. My p bar n, which is basically the probability of not having the birthdays coincide, is what? P bar n. I don't know what happened there. Oh, we have 100 people. Yeah, number of people, and then let's do this. Pn is 1 minus of that. So the probability of 2 people having the same birthday is 0.999999 with 100 people. How about with 10 people? Yeah, with 10, let's do the math right here. With 10 people, that probability is only 11.7%. So at the bottom part right here, I just put that in a for loop. and went through 0 through 100 and then plotting just to get the same plot as the one you saw on Wikipedia. So let's go ahead and run that. And there is your plot, and there you go. There is your 23 people with 0.5%. This is incredible. And this shows you the power of numbers. Yeah, only 23 people, even though you have 365 days to get it to a 50% probability. What am I trying to convey here? If you guys really want to be in data sciences and machine learning, you better practice a little bit of statistics, a lot of statistics, but get started with a little bit of statistics and try to understand these type of common thought-provoking exercises that are part of statistics courses. So I really hope you guys, I know this is a very simple concept or simple explainer video talking about random that you probably have used it many times, but I hope you learned at least something in this tutorial. Again, the best way for you to tell me that you really appreciate these type of videos is either by leaving the comments, leaving comments, or hitting the like button. Of course, subscribe to my channel. Thank you guys.